Next MCQ, question number 20. Suppose the gravitational force varies inversely as the n power of distance, then the time period of the planet in a circular orbit of radius r around the sun will be proportional to r raised to. So the power is given different in all the four choices. So we have to decide the exponential factor for r. Period depends on. So we know the basic relation for the period. So for our planet is our problem is for planet. For a planet, revolving around the earth, is period capital T is equal to 2 pi r upon v. This is equation 1, where r is equal to a radius of circular orbit. It is also equal to distance between. The second meaning of r is important. R is equal to distance between centers of Earth and the planet. V is equal to linear speed of the planet in circular orbit. So this is equation 1. Now second one, in circular motion of planet around the earth, centripetal force acting on planet due to earth is equal to gravitational force of attraction between earth and planet. Therefore CPF is equal to mg. So this is equal to mv square upon r is equal to gmm upon r raised to n. So this factor is important. Normally we take r square, here we have to take n square. This is equation second, because Fg is inversely proportional to, this is R, this is R. Mg is inversely proportional to R raised to N, like this. So this assumption is given. So mm will get cancel. So b square is equal to gm upon r raised to n. So gm upon r raised to n minus 1. Therefore v is equal to under root gm upon r raised to n minus 1. This is equation 3. So in this case m is equal to mass of orbiting planet. V is equal to, put 3 in 1. So period capital T is equal to 2 pi r upon under root gm upon r raised to Vt value r raised to n minus 1. So this is equal to 2 pi multiplied by under root gm r upon under root 1 upon r raised to n minus 1, that is equal to 2 pi upon under root gm r upon r raised to minus n minus 1 half by 2. N minus 1 by 2 root count करता. Therefore period is equal to 2 pi multiplied by under root gm, g constant, m constant, r raised to 1 and r raised to, this minus will become plus n minus 1 by 2. So this is equal to r into bracket 2 plus n minus 1 by 2. So that is equal to r raised to n plus 1 by 2. So period is directly proportional to r raised to n plus 1 by 2. R raised to n plus 1 by 2. ये बाकीचे क्वांटिटी कॉन्स्टेंट मध्ये जातील because 2 pi upon under root g capital M is equal to constant. So the correct choice is A. A is correct. आता n ची व्हॅल्यू काही पण देऊ शकतात. Suppose n is equal to 3, then it will be 3 plus 1 by 2, so that is equal to r raised to 2. So period will be directly proportional to r square, like this. So gravitational force is not inversely proportional to r square, but it is inversely proportional to r raised to. So this is the condition given in our problem. The gravitational force is not inversely proportional to r square, but it is inversely proportional to r raised to n. It 2 च्या ऐवजी इथे n आलेला आहे तो, and therefore this Gravitational force of attraction between the Earth and the planet is given by Gmm upon, instead of r square it is r raised to n, and therefore the final equation comes to be. आता पिरियडच्या ऐवजी दुसरी कुठली क्वांटिटी विचारली जाऊ शकते लक्षात. v इज इनवर्सली प्रोपोर्शनल टू, हे जर इक्वेशन आपण बघितलं तर v इज इनवर्सली प्रोपोर्शनल टू r raised to n-1/2. So one more question can also be asked. Equation 3 shows that critical velocity v is directly proportional to r raised to -n-1/2. When we remove the square root sign, we have to add 1/2, and this will go up, so it will become plus 1. So v is directly proportional to r raised to 1 minus n/2, like this. So you can find any quantity in circular motion, like this. This is the additional part. The linear speed will be directly proportional to 1 minus n/2, like this. Next, 21. If suddenly the gravitational force of attraction between the Earth and the satellite revolving around it becomes 0, then the satellite will A. Continue to move in its orbit with the same velocity, move tangentially to the original orbit with the same velocity. This is correct answer. Become stationary in its orbit, not possible, and move toward the Earth, not possible. So, what happens when centripetal force becomes 0? We have explained this point in circular motion. Centripetal force Fc is equal to mv square upon r is equal to mass multiplied by AC. When Fc is equal to 0, then acceleration AC is equal to 0. Therefore, dv by dt is equal to 0. Therefore, v is equal to constant. That is, velocity is constant means no change in direction and no change in magnitude. That is, there is no change in magnitude, there is no change in magnitude and direction of linear velocity. V. Therefore, the satellite will move. The satellite will not follow that is circular motion stops and linear motion along the tangent to the circle will start with the velocity same as in circular motion. So circular motion stops and linear motion along the tangent to the circle will start. Therefore, the correct choice is B. Question number 22. A satellite is launched in a circular orbit of radius r around the Earth. A second satellite is launched to an orbit of radius 1.01 times r. The period of the second satellite is longer than the first one approximately by value आपल्याला पर्सेंटेज मध्ये दिलेली. So here you can solve the problem by two methods. So such type of problem can be solved by two methods. One is normal method and second one is the error analysis method. We will see both the method. Method number 1. What is given? R1 is equal to R. R2 is equal to 1.01 R. T1, T2 new period minus T1 upon T1 multiplied by 100. Percentage मध्ये आन्सर आपल्याला फाइंड आउट करायचं आहे. Since T square is directly proportional to R cube, therefore T2 upon T2 square upon T1 square is equal to R2 cube upon R1 cube. Therefore T2 upon T1 whole bracket square is equal to R2 upon R1 bracket raised to 3 is equal to 1.01 R upon R bracket raised to 3, so that is equal to 1.01 bracket raised to 3. Therefore T2 upon T1 is equal to 1.01 bracket raised to 3 by 2. So this is equal to 1 raised to 3 by 2 plus 0.01 bracket raised to 3 by 2 like this. So this is equal to 1 plus, now this 0.01 raised to 3 by 2 by log it comes to be 0.01 multiplied by 3 by 2 approximately, neglecting the higher power terms. So this is equal to 1 plus 0.015 like this. So this is T2 upon T1. T2 upon T1. So T2 minus T1 is equal to T2 minus T1 upon T1 is equal to 1 plus 0.015 minus 1 upon 1. So this is equal to 0.015 upon 1. And therefore T2 minus T1 upon T1 multiplied by 100 is equal to 0.015 upon 1 multiplied by 100, that is equal to 1.5%. So T2 minus T1 upon original value T1 multiplied by 100 is equal to 1.5%. This is first method. So इथे आपण बायनॉमियल एक्सपेन्शन यूज करू शकतो. 0.01 raised to 3 by 2. It is approximately. Point 0.1 raised to 3 by 2 is nearly equal to 0.01 multiplied by 3 by 2 approximately. Approximately. You have to find the answer approximately. So this is one method. B. Method number 2. Error analysis method. Second method is error analysis method, and that method is the length. Since T square is directly proportional to R cube, therefore T square is equal to K R cube. Therefore T is equal to K dash R raised to 3 by 2. This is equation 1. Differentiating on both sides. Therefore dt is equal to K dash 3 by 2 we know the formula for integrating. So in the log table on the last page, the value of derivative is given. So derivative is this 3 by 2 into R raised to 3 by 2 minus 2. So this is equal to K dash K into R raised to 1. This is equation second. So 2 by 1 gives dt upon t is equal to K into 3 by 2 R raised to 1 half divided by K into R raised to 3 by 2. So K will get cancelled. So 3 by 2 this is dr. So dr upon R. This is equation capital A. So dt upon t multiplied by 100 is equal to 1.5 times dr upon r multiplied by 100. Percentage change in radius. So 1.5 dr is equal to 1.01 r minus r upon r multiplied by 100. So that is equal to 1.5 multiplied by 101 r upon r multiplied by 100. So this is equal to 1.5% dt upon t multiplied by 100 is equal to 1.5%. The answer दोन्ही ठिकाणी सारखं देईल. This is the error analysis method. If the radius changes by dr, increases by dr, then the period increases by dt. So this is increasing period upon original period. This is a percentage change in period. When you multiply by 100, we will get the answer in percentage. So here it is multiplied by 100, so it is in percent. It is in percent. It is in percent. That is. So in both the cases, actually we know the limitation of this method. If the percentage change is more than 5%, then this method is not applicable. Here the change is only 1%, so we can use this method. अशा आपण सिंपल पद्धतीचे पण काही प्रॉब्लेम सॉल्व केलेले आहेत. नेक्स्ट क्वेश्चन नंबर 23. An Earth satellite is moved from one stable circular orbit to farther, underline this, farther stable circular orbit. Which one of the following quantities increase? Linear orbital speed, gravitational force, centripetal acceleration, gravitational potential energy. So you have to check one by one. So we are increasing the radius. When satellite moves, satellite is shifted to outer stable circular orbit. Then radius r of the circular orbit increases. Radius of the circular orbit increases. Then now we will try the choices one by one. A choice. Linear speed v, linear or orbital speed v is equal to under root gm upon r. Therefore, as r increases, therefore v decreases. V decreases. Therefore, A is wrong. A is wrong. Now let us try B quantity. Gravitational force B. Gravitational force F is equal to Gmm upon R square. F is inversely proportional to R square. Therefore, as R increases, then force F decreases. Force F decreases. Therefore, B is wrong. B is wrong. Then next quantity is centripetal acceleration. C. Centripetal acceleration AC is equal to V square upon R. Therefore, AC is inversely proportional to R. Therefore, as R increases, then AC decreases. That C is wrong. So ABC is wrong, means D must be correct. And what is the quantity in D? That quantity is gravitational potential energy. B. Gravitational potential energy U is equal to, this minus sign is important, minus Gmm upon R. Due to negative sign, as R increases, then gravitational potential energy U also increases. As R increases, U also increases, and therefore D is correct. D is correct. So why ABC is wrong? जनरली थिअरी क्वेश्चन असतो तर आपण रॉंग चॉईसेस पण ट्राय करायला पाहिजे. नेक्स्ट, a 20 centimeter long capillary tube is dipped in water. The water rises up to the 8 centimeter. The entire arrangement is put in a freely falling elevator. The length of the water column in the capillary tube will be. So we are using the capillary experiment in freely falling elevator. So we should know the property of the freely falling like this. So capillary rise H is calculated by using this formula, 2t cos theta upon under root H, H ची आपण घेतले जाते root G R. T is a surface tension of liquid of water rho is equal to density of water, theta is equal to angle of contact of water with capillary, r is equal to radius of the capillary bore, and g is a gravitational acceleration. G is a gravitational acceleration due to Earth. So this is the question number 4. So in a freely falling elevator lift, effective value of gravitational acceleration is g dash is equal to g minus a, but a is equal to g, therefore g dash is equal to 0. Therefore capillary rates h dash is equal to, there is a change in gravitational acceleration 2 times p cos theta upon rho g dash r. Since g dash is equal to 0, therefore h dash is equal to infinity. But h dash is equal to infinity is never possible. But h dash is equal to infinity is never possible. So this is the result. So water rises up to maximum height, h max is equal to total length of the capillary. Therefore, in freely falling elevator H max is equal to L is equal to 20 centimeter. So in this case the length of the capillary tube is given 20 centimeter like this. So the maximum height obtainable is 20 centimeter and therefore correct choice is D. D is correct. So same question can be asked like this. If the capillarized experiment is performed in an orbiting satellite, So in the orbiting satellite, the same condition is there. Due to the state of zero gravity, due to the filling of weightlessness, g dash is again 0, so h dash is equal to infinity. But h dash cannot be infinity, so in the orbiting satellite, the maximum height will be again length of the capillary tube and it will be that given quantity. जी काही आपल्याला लेंथ दिली असेल तिथपर्यंत फक्त लिक्विड मॅक्झिमम राईज होऊ शकतो. सो मॅक्झिमम हाईट रिच्ड बाय द लिक्विड इन द कॅपिलरी इज इक्वल टू लेंथ अंडर द दिस झिरो ग्रॅव्हिटी स्टेट, वेदर इट इज ए capillarized experiment in a satellite orbiting around the earth or the freely falling elevator or at the center of the earth. जीच्या व्हॅल्यू 0 या 3-4 ठिकाणीच असतात, तर त्या सर्व ठिकाणी आपल्याला हाच रिझल्ट मिळेल. द एच मॅक्स इज इक्वल टू लेंथ ऑफ द कॅपिलरी ट्यूब अँड इट इज गिवन इन द प्रॉब्लेम. इन आवर प्रॉब्लेम इट इज 20 centimeter like this. Okay, we will stop here.